Let's look at 4.1, graph the reciprocal function. Here's your parent function. This is your parent function for any kind of rational function. Remember, rational means you have fractions. So let's take a look at this. Now, we'll start out by discussing domain. Recall that you cannot divide by 0. So therefore, x cannot equal 0. Cannot divide by 0 because this makes your function undefined. So when we're talking domain and range, my domain, the set of all x such that x cannot equal 0. So I can't use 0. It's undefined. Now let's talk range. Well, if you think about it, 0 isn't even allowed for x. The only way to, remember your fraction bar is division, the only way to get an answer of 0 is I'd have to have 0 in the denominator. And I'm never going to have 0 in the denominator because there's always going to be a 1 there. So no matter what number I put in for x, y will never ever equal 0. So we have a range restriction. Y cannot equal 0. Now, if we also think about your x and y intercepts, well, an x-intercept occurs when a y value is 0. So y can't equal 0, so therefore we can't have an x-intercept. If I'm looking at a y-intercept, well, y-intercepts occur on the y-axis where x equals 0. And so if x cannot equal 0, I can't have a y-intercept either. So there are no x or y intercepts. So what we have done here, these areas that are undefined are called asymptotes. And what an asymptote is, it's like a little boundary. So it's this boundary that the graph cannot cross. It will approach it. It's going to keep getting closer and closer and closer to it, to infinity, but it will never ever touch the line or cross it. So an asymptote is a line that a graph approaches. But again, this is a line that we don't see. So if you were to put this function into Desmos, you're not going to, your asymptotes are not just going to be listed there for you. You're going to see an empty space. This is also going to guide the end behavior of your function. In this course, we're going to work with two different asymptotes. We're going to work with vertical asymptotes and we will abbreviate that VA. And that occurs where you have a domain restriction. And it's going to be a line x equals some number. I'll just leave that as n. And of course, vertical line, and we usually draw these as dashes when we're graphing them. There's also horizontal asymptotes. And we can abbreviate that as HA, and that's your range restriction. And that is going to be y equals, and I'm just going to use m. These just represent some number. So now let's do this. Let's graph using a table of values and our asymptotes. See how much of this I can keep on. So let's graph. So we already know we have a vertical asymptote at x equals 0. We have a horizontal asymptote at y equals 0. Let's go ahead and put these in on our graph. So I have a vertical asymptote at x equals 0. Well, that's your y-axis. And that is my vertical asymptote. And then you have a horizontal asymptote at y equals 0, which is your x-axis. So that is right here. So my graph cannot cross these lines. Well, let's see what's going on. Whenever I graph using a table of values, I always try to choose some that are to the left of the vertical asymptote and some that are to the right. So let's create our t-chart. And let's remember that y equals 1 over x. Now, I'm just going to choose easy values. So if I come over here, let me do x equals -2. Well, that means y here is 1 over -2, so this is -1/2. Let's do x equals -1. That means 1 divided by -1 would give me -1. If I put 0 in, well, when x is 0, we already know we have an asymptote there. There's nothing happening when x is 0. So let's go to the right side. When x is 1, 1 divided by 1 is 1, the positive 1. And now let's do 2. And inputting 2 for x, we get 1/2. So now let's just graph these few points. This is really all you need. We might want to pull in a third on each side. Let's see. So when x is -2, 1, 2, my y value is -1/2. When x is -1, my y is -1. So I can tell here, just even by looking here, I know my graph is going to come and it's going to approach my horizontal asymptote but never cross. And then over here, it's going to come down. It's always going to be kind of pulled towards that vertical asymptote but never cross. Now going to the right, when x is +1, y is +1. And when x is 2, y is 1/2. So here it is again. It's going to come up, and it's going to get closer and closer and closer to this asymptote, but never cross it. In here, it's going to come down, and it's going to hug up against that horizontal asymptote. Let's kind of just take this opportunity and discuss end behavior. As x approaches positive infinity, where are my y values going? So as I look at this graph, as I go to positive infinity, notice your y values, because of this asymptote, they're going to be pulled into y equals 0, but again, it will never ever cross it. It will never ever touch it. So that means y is approaching 0. If we go the other way, as x approaches negative infinity, where are my y values going? So that means my y values are going, take a look, we're going over to negative infinity. My y values, again, they're coming up and up and up and up and up, but they're being kind of drawn to that asymptote, but they will never cross it, they will never touch it. So again, here, y approaches 0.